I am testing a WPC PowerDriver board and MPU board at the same time. And you can see, well, I have the WPC DMD test ROM running. You can see that row 7 is locked on. Now I'm going to hop into test, and we'll go to single lamp test. And there you can clearly see that row 7 is locked on. And here's all lamp test, and you can still see that column 7 is locked on. So, I'm sorry, row 7. These are the row transistors. These are the column drive transistors. These are tip 107s. They let 18 volts flow into the lamp matrix. And then these tip 102s provide the path to ground for that current that is being passed through these tip 107s. Here's the 18 volt test point. So the software in the game will use this upstream circuitry to turn on this transistor, and I didn't do that right, but that will be to light, say, column 8, row 8 lamp. So one of these row transistors is shorted. Now I looked it up. It turns out they go like this: 8, 7, 6, 5, 4, 3, 2, 1. And I'm going to put that in the pin wiki just to make it easier for me in the future. I'm going to power off, and we're going to see if we can use a multimeter to see if that transistor is damaged in some way. So I've connected black to a convenient ground test point. And if I can just get my thumbs out of the way, and we're going to measure resistance, meter set to ohms, between the tabs of each of these row transistors and ground, and they should all be open. You can see that one's not. It's at 10K. Open, 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 open. Let me do that one more time on camera. These are all open, except for that one. Now that one is Q84. If we go up to our schematics, Q84, sure enough, that is the row 7 transistor. So let me get that swapped out, and I'll be right back. All right, we are on the bench with this driver board that's got a failed tip 102, and we need to get this component out. It's a tip 102, and put a gold dot next to it. So let me show you how I like to get these out these days. So I've got my kind of a fat iron tip. It's not as big as the blade one I use, but anybody can get a tip that's this width versus the big one that I typically use. So you can see I added a bunch of solder to that component, and I'm going to grab it from the back side, or the component side, and then I'm just going to keep heating this solder up, and out the part comes cleanly. And then I can take my solder sucker, whatever you like to use. This is a FR301, and clean up these holes. Lingered there a little too long. Sometimes if you don't have enough solder on the hole, the FR301 doesn't want to pull it out. So there I added a little bit of solder. Got the new part marked with my characteristic gold stripe. And let's fit this part in from the other side of the board. Easier said than done, apparently. There we go. And I know I said I hate it when Rotten Dog does this, but I don't have enough hands, so I'm going to bend one of the legs there so it stays in place for just a moment. Come back with my iron. you can solder in any order you want, but I typically start in the center. I'm going to bend that leg back to where it was and then finish the job. And then we get some side cutters out, and we can cut all 3 legs at the same time. Get my cleaning solution out, which is acetone. Kind of a nasty chemical, but that's what I like to use because it does the best job. It doesn't leave a residue like naphtha, which is basically lighter fluid, does. So let's see. There's the part installed. I couldn't pay too much attention. I got it in there a little crooked. If you're not videotaping, you can probably do a better job than I did. Back on the bench with this WPC PowerDriver board, which we just changed out Q84 at tip 102, and you can see that row 7 is no longer locked on. There's some ghosting, a little bit of ghosting, but that's because this is an LED block. So there is no such thing as a non-ghosting LED block that I'm aware of. So there's the tip 102 that we replaced, and this driver board is now good to go.